Okay. So f of x and g of x, right? They just kind of replace y, don't they, in an equation? And it's just a little bit more useful, you know, when you get into, you know, higher level mathematics to use function notation like this, okay? So down here, let's just take a look at exercise 1 here. I have a note for that, I did not. All right. So instead of saying here in part A, y equals 5x minus 2, they're just saying f of x. So f, right, the name of this function is f, and it's a function of an input x, okay? So this f of x depends on the value of x that you plug in, all right? You with me? The independent variable, the input. So for f of negative 2, right, if we want to evaluate this, well, this negative 2 replaced what up here?
X.
X. So then everywhere else, you replace the x with negative 2, okay? So we'd have 5, quite simply, times negative 2 minus 2, right? So f, continuing on, negative 2 equals, that'd be negative 10 minus 2. So what does f of negative 2 actually output? Negative 12, right? Okay. Y'all get the idea there? So why don't you guys, looking at the way I did this, evaluate B and C on your own for a moment. I'll give you a minute or so. Plug them in, make your work look like the way I did, and we'll see how you do. Go ahead and take a minute and do B and C. So what did we get for B?
20.
20, right? So you replace this with 4, so you got, whoops, 4 squared plus 4, right? Continuing on, you wrote g of 4 equals 16 plus 4. And ultimately, g of that input 4 results in an output of 20. Anybody get C yet?
Yeah, it's 16, right?
It's 16?
Yeah.
I don't know about 16. 8, right? 2 to the third. 2 times 2 times 2, right? So 2 times 2 is 4. Times 2 is 8. Okay? You're 1 factor of 2 off. Right? All right, so down here, they officially give you the function notation, right? Where here, y is the output, f of x, that's the rule, right, or the input of the relationship. So, but f of x just replaces y. Okay? Or you might see it as g of x, right? Or, I don't know, h of t. Like if you have an equation that relates to something happening with time instead of like x, okay? Etc. Okay? Let's go down here. So again, our function rules can come in 3 forms, right? Our relationship can be described with an equation, right? It can be described with a graph or a table of values, okay? So down here in exercise 2, and it looks like there was some formatting that went sideways when this got converted to a PDF. So this should be a table down here. You can just kind of sketch that in real quick. And I think in your homework book, it probably has a couple like that, but shouldn't matter too much. Grid. Okay. So this is a little science relationship here between time and temperature, right? Heating something up. So we're talking about boiling water, right? Water boils at 212 degrees. Hopefully you all know that. What does water freeze at, by the way? Anybody know? What temperature?
But it's like 30.
32 degrees. Boils at 212 and freezes at 32, okay? So they boiled water and they left it sit in a room and the temperature of the room is 65 degrees. That would be, you call that the ambient temperature, right? The temperature surrounding the thing you're looking at, okay? And so what do you think happens to the water as it sits there?
Just slowly decreases and.
Yeah. Good. So as time increases, the temperature does what?
Decrease.
Okay. So what is the input here in this relationship?
Hours.
Yeah, time, right? It's independent. It just happens, okay? And the output, the dependent value would be what?
Temperature.
Temperature, right? Okay. So here's a table of values. And the time they're measuring in hours, right? Not minutes or anything, so that's important to know. So when you first boil it, 0 hours have passed. The temperature, of course, you know, you take it off the stove, it's 212. After 1 hour, it's down to 141, etc. And you go all the way out here to 8 hours, right? It's now at room temperature, 65, okay? It's reached what they call equilibrium, right? Like all systems tend towards equilibrium, right? That boiling water is going to become equal to the temperature in the room, okay? So they want us to evaluate down here in part A, T of 2, right? Temperature as a function of 2 hours and as a function of 6 hours. Well, all we have to do is take a look at the chart, right? So T of 2, we input 2 hours, and what's the output temperature?
104.
104 degrees. After 6 hours, for an input of 6 hours, what's our output temperature?
68.
68 degrees, okay? So now in part B, they're kind of asking this in reverse here, right? For what value of H? In other words, after how many hours, right, is the output value of a relationship 76 degrees? What would you say?
Four.
4 hours, okay? See how they're asking that in the inverse, right? Okay? And finally, part C, between what 2 consecutive hours will our temperature be 100 degrees? Between what 2 consecutive hours?
2 and 3.
2 and 3, right? So we would say between 2 and 3. We could also write that like this mathematically, right? All right, you've seen that before. And a lot of kids try to read that literally, right? 2 is less than or equal to H, less than or equal to 3. And it might be hard to kind of understand what that means. But when you see an inequality like I just wrote there, you might as well just say to yourself, to keep it simple in your brain, just say, okay, H is between 2 and 3. Okay? That's all I need to know about that. Okay? All right, let's go over to exercise 3. Top of the next page. Now they've given us a graph, a graphical representation of a relationship. Okay? XY axis, and again, the Y would be the outputs, right? And the X would be the what?
Input.
Input. Right? Inputs go along that X-axis. Or, you know, if it was the relationship we used in the last example, we wouldn't use X, we'd use H, right? And the Y would become the T for temperature. Okay. All right. So they want us to evaluate F of -1, 1, and 5. So let's start with F of -1. Go over to the graph, find -1 on the X-axis, and what's the output value of Y?
4.
4? We're at -1, -1.
0.
0, right? Okay, so F of -1 equals 0. And by the way, wouldn't we call that a 0 of the graph, right? Remember finding zeros of graphs? It's where the graph crosses the x-axis, okay? What is f of 1, an input of 1? What is the output for f of 1?
4.
It's up there at 4, okay? And finally, f of 5, that input gives us an output of what?
Negative 4.
Negative 4, okay? So you can get your input and output values not only from the table, but from a graph, okay? In part B, they want us to evaluate f of 0, okay? So let's go to f of 0. And what is the value there?
Three.
3, right? F of 0 equals 3. Who knows what we call that particular point? It's hitting the y-axis. Okay? So that is where the graph intercepts the y-axis. Any idea what the name of that is? Where the graph intercepts the y-axis. Might be called the y something. The y something. It's where it intercepts the y-axis.
Y-intercept?
Oh, the y-intercept. You guys are sharp today. That's called the y-intercept. And anytime you're crossing the y-axis, what's the value of x, the input? Anytime you cross the y-axis, what is the value of x at that point?
X equals 0.
Right. X equals 0 where you cross the y-axis, right? And so the coordinates of that point in this case would be 0, 3. That's the y-intercept. All right? You know, like y equals mx plus b. The b, remember, was the y-intercept, right? Because put in a 0 for x. What's m times 0?
Zero.
0 plus b is just b. So y equals b where x equals 0. All right? Let's go down here to part C. What values of x? Solve the equation f of x. And f of x is just whatever equation, right, generated that graph. Okay? That looks like some kind of sine curve or something, by the way. So what values will make that equal 0? In other words, the y values, right, will equal 0. What values of x?
-1.
X equals -1 will cause it to be 0. What else?
X equals 3.
At x equals 3, there's another one.
And X equals 7.
And x equals 7, right? So if we go up here and look at x equals -1, well, the graph is at 0, right? We go over here to x equals 3, graph's at 0, and x equals 7, the graph is at 0. So those x values, -1, 3, and 7, are the zeros of this relationship, okay? All right, let's go to part D. Between what two consecutive integers does the largest solution of x lie? In other words, the max. So between what two x values will you find the max of this? What two? The highest value. I'm sorry. Wait a minute. Oh, yeah. For f of x equals 3, y equals 3. Okay, yeah, my mistake. So between what two x values do you find the max of f of x equals 3? Well, let's find out where it equals 3. So here's the line for y equals 3, isn't it? That make sense? So between what two x values do you find the max?
X equals 0, x equals 0, and x equals 7.5.
Well, and they want consecutive integers, right? Wouldn't you say it'd be like between 7 and 8 here?
Yeah,
Because the graph goes off the page at that point, doesn't it? Does that make some sense? That question's kind of confusing the way they worded it, honestly. I'm not sure if I like that now that I look at it again. And this may happen a time or two as we go along, as this is the first time I'm looking at this curriculum. I don't really care for the way they ask that question, but we'll just answer it with between 7 and 8. Okay? All right, let's move along down here. Exercise 4. So we have a function y equals g of x, right? Whatever equation that is, they don't tell us, okay? It is known that g of -2 equals 7, okay? So g, -2 would be the x value, right? Good gravy. Oh, I could make it quit doing that. -2 would be our x value, and 7 would be our y value, right? So in other words, what would be the coordinates of the point they're describing here? What comma what?
-2, 7.
-2, comma 7, okay? So which of the following points must lie on the graph of g of x? If g of -2 equals 7.
-2 equals 7. Negative number
Right.
2.
The one we just wrote, right? That's the only one we can say for sure that must lie on there, okay? And that's just an exercise in knowing that this is your x and that is your output y. Input x, output y, as it relates to that function notation, okay? So does anybody have any question on functions? That should be kind of a review for you, right? Okay? All right. So we can squeeze one more lesson in here. Let me stop this recording and save it.